There's a dangerous illusion at the heart of AI-assisted coding. Code that looks right, runs without errors, and produces output that seems reasonable. But seems reasonable and actually correct are two very different things, and the gap between them is exactly where production systems silently fail at 3 in the morning. Plausible code compiles. It runs. It even returns the right answer on your demo dataset. Correct code is something else entirely. It respects edge cases, honors data constraints, and doesn't quietly corrupt your database when an unexpected traffic spike hits on a Tuesday afternoon. Most AI coding demos only ever show you the happy path, which is precisely why the distinction is so easy to miss. LLMs are trained to predict the next token that statistically resembles good code, not to verify that the logic is sound. These are fundamentally different objectives. A human expert asks, does this code do what we need it to do in this specific context? A language model asks, what sequence of characters most resembles correct-looking code given what I've seen before? One is reasoning about intent. The other is sophisticated pattern matching. SQL generated by LLMs is a particularly treacherous category. A query might return perfectly correct results on your small test dataset, then silently perform a full table scan on 10 million production rows. Joined semantics might quietly drop records you needed to keep. Null handling can be technically valid but completely wrong for your business logic. None of this throws an error. None of it shows up in logs. It just produces subtly wrong numbers that slowly erode trust in your data. The evaluation infrastructure we've built around coding models still fundamentally measures plausibility. Pass rate on unit tests is a commonly cited metric, but when the same model that wrote the code also wrote the tests, you're measuring internal consistency, not correctness. It's like grading your own exam. The model can produce a perfectly coherent, internally consistent system that is wrong in exactly the same way throughout every layer. Engineers extracting real value from AI coding tools share 3 habits. First, they treat every LLM output as a draft requiring domain expert review, never as a finished solution. Second, they write their own tests before prompting the model, defining correctness before inviting plausibility. Third, they apply dramatically more scrutiny to generated database logic than to UI code, because database failure modes are invisible until they've already done damage. The tool is valuable. The discipline around it is what makes it safe. The engineers getting the most leverage from AI coding tools are not the ones who trust it most. They're the ones who understand its actual reasoning boundaries most precisely. They know which problems are well within the model's strengths and which require human judgment to catch failure modes the model cannot even perceive. This isn't a criticism of the technology. It's an accurate map of a landscape that the hype cycle consistently misrepresents. The difference between plausible and correct is not a minor technical footnote. It's the entire challenge of software engineering made visible in a new way. AI tools compress the time to plausible dramatically. They barely touch the distance from plausible to correct. That remaining gap is still filled by human expertise, rigorous testing, and domain knowledge. Understanding that clearly is what separates engineers who build reliable systems with AI from those who ship quietly broken ones.